Hi friends, this is Srinivasulu, branch of CSC, Ashankara Institute of Science and Technology, Gudu. This is my OOAD, Object Oriented Analysis and Design, third year, second semester tech talk presentation video. In this video, we can explain that chapter 1, Object Oriented Analysis and Design. There are the concepts of Object Oriented OBO and Object Oriented Method OBOM, Object Oriented Modeling, Polymorphism, Inheritance, Object Oriented Analysis and Design, Jacobian Use Case Method, OVO Software Engineering, OVOSE. System deployment, requirement model, analysis model, design model, implementation model, test model, unified modeling language, UML, the value of UML, history of UML, overview of the UML. Chapter 1, Object Oriented Analysis and Design. What is an object? Definition. An object is a software bundle of variable and related methods. As, as the name object oriented implies, objects are keys to understanding object oriented technology. You can look around you now and see many examples of real world objects. Your dog, your desk, your television set, your bicycle. Software objects are modeled after real world objects in that they too have state and behavior. A software object maintains its state in variables and implements its behavior with methods. Object orientation, analysis, design, implementation. Analysis means investigation of the problem. Design, logical solution. Implementation, code. Object oriented analysis, investigation that is object centric. Object oriented design, solution in terms of interacting software objects. Object oriented programming, coding in an object oriented programming language. Over modeling, object oriented modeling. This is the see that in this picture we have see tree next to house. Henry lives in house and Henry drives a car. In this picture we see that the tree next to the house and Henry lives in a house and Henry drives the car. In this picture we have seen that we can explain that see the picture to explain all about the picture and information. The basic object classes relationships and instance idea of encapsulation. An object, some concept of reality, a physical entity. It is characterized by a number of operations, a state which remembers the effect of these operations. An object operations work, dance, drive, jump, attributes, height, high color, air color, weight. Relationship static. Relation exists over a long time. Objects know about each other extends dynamic. Relations which two objects communicate with each other. Objects sending simulation to other similar events messages. Creating objects. Composition structure object from parts. Partition into hierarchy is a consist of build objects from others. Aggregate to join together as a encapsulation. A concept of self-containing information hiding. Internal structure is hidden their surroundings. Behavior and information is represented or implemented internally. Functionality and behavior characterized by interfacing operations. Class. A class represents a template for several objects and describes how these objects are structured internally. In class describes that template that several objects and a structure of these objects internally. Objects of same class have the same definition both for the operations and their information structure. Class is the implementation of objects. Key concepts. Polymorphism. Same object has different implementation entities. In this polymorphism, we have seen that poly means many, morphism means forms. Inheritance. To adapt, permutate and derive some generic operations. Inheritance means we have granted or taken to the properties of old generation to new. Polymorphism. A concept is the theory. A common name may denote instance of different classes. One type of operation can be implemented in different ways by different classes. Overloading in modern over language. Why polymorphism? A very strong tool for allowing system designers to develop flexible systems. Designer only need to specify what shall occur and not how it shall occur. To add an object, the modification will only affect the new object, not those using it. Inheritance. If class B inherits class A, then both the operations and the information structure described in class A will become part of class B. A simple data model. Member order placed by places. Member is enrolled by applies to agreement. Established by establishes club and sponsors is sponsored by promotion is the future in futures product sales is sold on generates generated by a simple object model student id number name grade point average admit registration for classes withdraw change address calculate gpa graduate graduate has record for course subject number title credit create a course delete from course master change in course master transcript course semester division grade add drop complete change grade object oriented methods advocate integral objects which encapsulate both function and data. Main activities include identification of objects and analyzing their behavior and information. Uses object-oriented techniques and ideas. Inheritance, polymorphism, function and data abstraction. Object-oriented analysis and design. Finding a 1. Finding a object. 2. Organizing objects. 3. Describing how objects interact. 4. Defining the operations of objects. 5. Defining objects internally. Finding objects. Naturally occurring entities physical. A concept of some abstract ideas conceptual should be stable. Classes of objects. Active, passive, temporary, permanent, persistent, part to whole, generic, specific, private, public. Organizing object classification similar object inheritance is a interactions relationships between objects whole part relationship has a describing how objects interacts object interacts identify how objects fit into a system use of scenarios unique situations objects communication objects interfaces define relationships defining the operations of objects object functionality object implementation and testing of objects object functionality operations performed by an object behavior of an object specification of interfaces external and internal functions objects with complex functionality should be partitioned into simpler objects object implementation the specification of classes definition information that an object encapsulates attributes and methods automobile color made travel sound horn open sunroof object implementation methods specify external functions specify internal functions that are not seen or usable by other objects languages c++ smalltalk ada fl modular 2 simula java++ requirement use case model actor 1 uses use case 1 use case 2 actor 3 uses use case 1 use case 2 actor 2 uses use case 1 uses 2 system in the three actors are using in the system requirement use case model system to the use cases from three actors also requirement model actor 1 actors essential system entities from an user viewpoint interacts with the system changes system behavior control system functionality analysis model structure a system independently to the actual implementation capture information behavior and presentation specify objects design model define the object structure to the chosen implementation environment objects are consolidated into blocks abstracted classes blocks interactions are also documented using interactions diagrams. Implementation model. The blocks of the design model are implemented using classes. Class diagrams are used to express relationships between the classes, class specifications, annotated source code, pseudocode for methods and attributes for of classes. Class diagrams inheritance. Class A type check status persistent. Class B type check status generate report persistent. Class diagram aggregation. Class A type check status persistent has A. Class D, Class C. Class diagram uses Class A type check status persistent. You use the GUI user interface, guest user interface. Class diagram and example: GUI, FMC workstation, robot, machine center, MC mission, NC mission. In FMC will consist of robot, machine center and machine NC mission. Object diagrams GUI load NC program to start checking. 4 ready to operate. 3 status of OK. Machine center A. Test model states the method and result of testing. Test specification describe how classes and system are able to test. Test results document outcome of the tests executed, verification and validation. Unified Modeling Language UML. Overview of the UML. The UML is language of visualizing, specifying, constructing, documenting the artifacts of a software intensive system. Unified modeling language. Graphic tools. A model is a complete description of a system from a particular persistence. Use case diagrams, class diagrams, object diagrams, component diagrams, deployment diagrams, activity diagrams, state chart diagrams, collaboration diagrams, sequence diagrams. The end. And thank you to one and all to giving this great opportunity for me, and thanks to all.